I have gone and done it. Answered every normal distribution past paper question for the Statistics 1 paper. And in this resource, which is over 120 pages long, has 90 past paper questions on the normal distribution. You have what paper they're from, and you have all of my detailed solutions to these questions. And they're all categorized into those different styles, which you should know from watching my exam hack videos on the normal distribution, which explain these styles. I will put links for those in the description, but in this resource you have my personal answers to over 90 past paper questions on the normal distribution, all here. This is a massive resource and took me a long time to make, and this resource will be available for my Patreons. So you can go over there, become a Patreon for $5, and then you'll be able to download this resource and many more high quality resources like this in the future. But in this video, we're simply going to be going through lots of questions from these worksheets. Okay, so let's do some questions from that resource. All of these will be normal distribution questions. And you'll get a real good sense of my procedure for answering all of these different styles of questions. So we are given in the first one, we're given this. Remember, these is always of the form this is our mean here, and this is our variance. So that's our standard deviation squared. So given this, so let's write that out. With a mean of 31.4 and a and a variance of 3.6. Find the probability that a randomly chosen value of x is less than, so we want the probability that x is less than 29.4. So what we do there is immediately, what I always do is I draw out the situation. So we have a normal distribution, it has a mean of 31.4, and we want to find this. So let's say our 29.4 is here. So we want to find this area. So what is this area? Well, how we do that is we find the corresponding z value, and then we use our table. So we have z will equal to 29.4 minus 31.4 divided by standard deviation, which is the square root of 3.6. And what does that equal? We get 29.4 minus 31.4 divided by the square root of 3.6. We get minus 1.054. So let's have a look at this. So the corresponding z value, or z distribution, you'll get this. This is your z. It's a pretty gross line. And so the corresponding z value for this is minus 1.054. We want this area. Well, because this is symmetric, we can say that this is the same as saying finding this 1.054, same as finding this area for z. So we can say, first of all, now that we know that the probability, to find the probability that x is less than 29.4, well, this is the same as trying to find the probability that z is less than minus 1.054. Okay, so if we find this, then we can find that. So the probability that z is less than negative 1.054, well, this equals the probability, and I'm going to be super explicit here, z is greater than 1.054, and that is the same as saying 1 minus the probability that z is less than 1.054, right? This area here is 1 minus this area here. And this we can find from the table. So this is 1 minus, this is the symbol for it, 1.054. So then we go to our table and we look for 1.05 and then 4, we add a 9, so it's going to be 0.854. So this is 1 minus 0.854. So we get 1 minus 0.854. This gives us 0.146. is equal to 0.146. So therefore we can say the probability that x is less than 29.4 is equal to 0.146. And that's your answer. Okay, another question. The volume of ink of a certain type of ink cartridge has a normal distribution. So let's say X is the volume of our inks, and that is normally distributed with a mean of 30 and a standard deviation of 1.5. So people in the office use a total of 8 cartridges per month. So they use a total of 8 every month. Find the expected number of cartridges per month that contains less than 28.9 milliliters. Well, if we find the probability that X is less than 28.9, then we can find the expected number of cartridges that will have less than 28.9, which we'll just times it by 8. So let's find this. Well, what we do again is we draw out the situation. We have this normal distribution, and this is 30, and this is 28.9. We want this area here, like before. So let's find the corresponding z-value. Well, this is 28.9 minus 30 divided by the standard deviation, which is 1.5. Put that into our calculator. And it's good that we're getting a negative number, because we can see it's on the left side, which will be negative z-values. So this is minus 0.733. So therefore we can now say that the probability that X is less than 28.9, this is the same as saying the probability that Z is less than negative 0.733. So let's find this. Whoa. Ooh. So this is our negative 0.733. This is for Z and X. So these areas are the same. Well, this is the same as saying, I don't have to draw it, but we can say this is the same as saying, this positive 0.733, it's the same area, and this area, so we can say the probability that Z is less than negative 0.733. Well, this is equal to the probability that Z is greater than 0.733. And this equals 1 minus the probability that Z is less than 0.733. And the reason we do that is because we can actually find this value on the table. And this is, in the correct notation, equal to this. So we go look for this value on the table. So 0.733, we add 9 to this, will give us 7,682. 1 minus 0.7682. So let's do that. 1 minus 0.7682 gives us 0.2318. So therefore, the probability that X is less than 28.9, 28.9, this is equal to 0.2318. And well, what is that? Well, then we can find the expected number of cartridges per month that contain less than 28.9 milliliters. So we can say the expected number of ink cartridges equals 0.2318 times 8. So we times that by 8. And that gives us 1.85. You can't have 0.85 of a cartridge, so we can say it's 2. Expected number will be 2. It's closest to 2. So we can say expected number is 2. Cool, and that's your answer there. Let's keep going. You'll notice that we're going through different styles. You'll see that by the coloring. So we're given this. normal distribution. 49 is the variance, remember, so this standard deviation will actually be 7, square root of 49. It's given that this is equal to 0.25, and it wants us to find the value of k. Well, again, what do? We simply draw out the situation. Whoa. So we've got 20, and this is k, and this is 0.25. And I know it's on the right side because this area of half of it is 0.5. So again, well, what is k going to be? We can find that through finding the z value. Well, z is equal to k minus 20 divided by the square root of this, which is 7. Okay, so if this is 0.25, then this is 0.75. And the reason that helps us is that, well, this z value here is going to be able to be found with this. So we know that this, the z value, will be the one equivalent to the probability of 0.75, and we can find this from the table. So we look for what z value gives a probability of 0.75. Well, that'll be, we have 7486 here, so let's look, plus 86 plus, let's say, 13, so we get 0.7486 plus 13, so that's 0.674. 0.674. So the z value, which corresponds to this area here, is 0.674. So therefore we can say that 0.674 equals to this, k minus 20 over 7. So now we can find k. So you know 0.674 times 7, and then we plus 20. So it's 24.7 is your answer. K equals 24.7. Cool, let's do another one. The time x in hours for which student use a game machine in any given day is normally distributed. So again, we draw this out. It's normally distributed with a mean of 3.24 and a standard deviation of 0.96. And it wants us to find the expected number in a year of students that use the game machine for less than 4 hours. Well, we need to find the probability, and this is squared, probability that x is less than 4. If we find that, then we can find the expected number of days in a year that children use this machine, or people use this machine for less than 4 hours. So let's draw out the situation. So this is I. So 4, if this is 3.24, then 4 is on this side. So we want to know what this area is. What is this area? Well, let's find the corresponding z value for this, which is going to be 3.24, it's going to be 4 minus 3.24. And if you're ever confused about, well, do I go 4 minus 3.24 or 3.24 minus 4, maybe you forget. Well, if you think about it, if 4 is on the right side of the mean, that means the z value is definitely going to be positive. So I know it's going to be 4 minus 3.24. This divided by 0.96. So this gives us our corresponding z value, 4 minus 3.24 divided by 0.96. And this is 0.912. Oh no, 792. 0.792. So that means, this looks like this, 0.792. And we want this area. Well, that means that the probability of x is less than 4 equal to the probability that z is less than 0.792. And that just equals this value on the table. So we go look for 0.792. So we go 0.792 is 7858. So this equals 0.7858. Okay, so therefore the probability that x is less than 4 is equal to 0.7858. And therefore the expected, the expected number of days in a year that people use this machine less than 4 for 4 hours is going to be this times 365. So the expected is equal to 0.7858 times 365, which equals times 365 is 0.7858. Times 365 is 286.8. 286.8. So we can say that's closest to 287 days. So expected equals 287 days. Cool. Then II. Find the value of k such that P of x is greater than k equals 0.2, and it wants us to find the value of k. So again, we know this is for our 3.24 and 0.96. 3.24 comma 0.96 squared. So let's have a look at what this looks like. So you have a k, and then this is 0.2, and this is your 3.24. So what's the corresponding z-value? You can see this a lot. I mean, it's the same thing over and over again. The procedure is the same, guys. This is then k minus 3.24 over 0.96. So we find the corresponding z-value. Well, this is 0.8. Well, that means that if we want to find this z-value here, what's the z-value that corresponds to a 0.8 area here? So we look up on our table, what is the z-value that corresponds to that? So z will equal so 0.8 is let's say 0.84 plus 5. So this is 0.842. 0.842. 0.842. Okay, so now we can find the k value. So therefore we have 0.842 equals k minus 3.24 divided by 0.96. So we get k equals, or we do 0.842 times 0.96 plus 3.24. So we get 4.05. Cool, so that's that one done, and then finally find the probability that the number of hours for which a randomly chosen student uses the machine in a day within 1.5 standard deviations of the mean. So this wants us to find the probability that it is 1.5 standard deviations from the mean. That's minus 1.5 from the mean and plus 1.5 standard deviations from the mean. So it basically wants us to find this. What is that? Right? And you could just sub it all in to this. So you could sub in your mean and your standard deviation, you get two values. But if you just think about it, because of the z value is the value of 1 0.5 here means 1.5 standard deviations from the mean. That's what the z-value means. If you don't, you need to go and understand that. So basically this is just asking you for this. So this is the same as saying the probability, and the z is between minus 1.5 and 1.5. So if you find this, you can find that. So what is that? Well, the probability that z is between 1.5, minus 1.5 and 5 is going to equal to, well, if you think about it, it's going to be this, so the probability that it's less than 1.5, so the probability that z is less than 1.5, minus the probability that z is less than minus 1.5, minus the probability that z is less than minus 1.5. Well, this we can find from the table, but this we can't. So we need to just manipulate this more. This is going to equal to 0.5 minus, well, what is this? This is, if we just look at it, so this is like, looks like this, right? We can just think about it, you know, we've done this before. Minus 1.5 area. Well, this is the same as saying this area greater than 1.5. It's the same as saying z greater than 1.5. And this is the same as saying one minus the probability that z is less than 1.5. Yeah, if you had this, this area is 1 minus, I'm going to find this area as 1 minus the probability that z is less than 1.5, so all this area. So this is 1 minus the probability that z is less than 1.5. And we can find these values from the table. It's 1.5 minus 1 minus minus is plus, and this is also 1.5. So you could say this is 2 times this value from the table. The z is less than, probability that z is less than 1.5 minus 1. Well, let's find this. What's the probability that z is less than 1.5? 1.50 is 0.9332. So this equals 2 times 0.9332 minus 1. What does that equal? 0.9332 times 2 minus 1 is 0.866. So therefore the probability that it's between, it's 1 standard deviation from the mean, which is equivalent to saying this, is 0.866. Okay, another question. So this one we can see is going to be a use an approximation style. So we're given that blank CDs are packed into boxes of 30. The probability that a blank CD is faulty is 0.04. So we could write that down. The probability of faulty equals 0.04. So the probability a CD is faulty is 0.04. A box is rejected if more than 2 of the blank CDs are faulty. Find the probability that a box is rejected. Well, if we could say that x, let's say x, our random binomial variable, is the number of faulty CDs, you know, in the 30 that we're given, well, we can say that the probability that a box is rejected, well, this is equal to the probability that x, the number of faulty CDs, is more than 2. And we can say that that's the same as 1 minus the probability that x is less than or equal to 2, because we don't want to find 3, 4, 5, 6 all the way up to 30. So this equals 1 minus the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. And well, what does that equal? We get 1 minus, we put this into our binomial formula. This is 30 because our n is 30. 0 times the probability of success, which is the probability that it's faulty, and obviously the probability of failure here is 0.96, 1 minus this. So you get 0.04 to the power of 0 times 0.96 to the power of 30 plus 31, 0.04, and you just plug all these in, plus 2, we get 32 times 0.04 squared times 0.9628. And I did this before, and this equals to 0.1169. 0.1169. So that's the probability that a box is rejected. We'll say call it PR. II. It says now we get 280 boxes are chosen at random. Use a approximation to find the probability that at least 30 of the boxes are rejected. Well, we could say now we could use a Y is the number of boxes that are rejected, you know, of that 280. So N is 280. And it wants us to find the probability that Y, and you know the probability of success here is if a box is rejected, which is this. So the probability of success is 0.1169, and that means the probability of failure is 1 minus that, which is 0.8831. 0.8831. We want to find the probability that Y is greater than 30 or equal to. So it's at least, right? At least 30 boxes are rejected. So what is this? Well, it'll be pretty hard to find if we were to do it through using your binomial formula. But this is a binomial, so we use an approximation, right? So we're going to approximate with the normal distribution. But we have this binomial distribution here with, you know, 280. This is our N, and our probability of success is 0.1169. Right? And so we're going to approximate this with a normal distribution. So our normal distribution for Y, is, our mean of that is going to be NP, which equals to 280 times 0.1169, which equals 280 times 0.169, which equals 32.73. And then our variance is NPQ, which is 280 times 0.1169 times 0.8831. So times 0.8831 is 28.9. Just 28.9. Okay. So there we can then approximate this, the distribution of Y with a normal distribution. So Y is then normally distributed with a mean of 32.73 and a variance of 28.9. Okay. So now let's ask, well, what's the probability that Y is greater than or equal to 30? Well, actually, a better approximation is to say that this is the same as saying the probability that Y is greater than or equal to 29.5. And that's again due to the way you're approximating. So you can, you know, look at this. Remember, it's these bars. I've said this before in the exam hack video, but you know, if you're looking for 30, you know, greater than or equal to 30, well, you're calculating all this area. But you've got to remember you're including that 30 bar because these are bars. So 30, 31, 32. So you've missed this bit here, which is the, you know, this is 29.5. So a better approximation is calculating from 29.5. So you include this entire bar. So we find this. Well, what's this? Well, we need to find the corresponding z value. So we need to find the probability that Y is greater than 29.5. Well, what's the corresponding z value for this? Well, z is equal to 29.5 minus our mean, which is 32.73, divided by the square root of 28.9. And this gives a corresponding z value of, So we got 29.5 minus 32.73 divided by answer is minus 0.6008. 6008. So therefore the probability that y is greater than 29.5 equals the probability that z is greater than negative 0.6008. And that equals to 1 minus the probability that z is less than 0.6008, which is 1 minus this. And I looked at this before, so I don't have to keep going to the table. And this is equal to 0.726. 0.726. So if you look up this value on the table and do 1 minus that, you'll get this. So that means that the probability that y is greater than or equal to 30 is equal to 0.726. Okay, let's continue with now some getting a little bit harder. Well, these are probably the hardest normal distribution questions they'll ask you. So you're given a random variable again, x, which has a normal distribution. So we write that out with a mean and an unknown standard deviation. You are given that the standard deviation is related to the mean by this, 2.5 of the mean. And you're also given that the probability of x is less than 6.8 is equal to 0.75. So what do we always do? Well, we draw out the situation. Let's have a look at this. What have we got? What have we got? And we want to find the mean. That's what they want us to do. So we're given that this probability is 6.8. This area here is 0.75. And this is the mean. So let's find the corresponding z value. Well, the corresponding z value for this is going to equal to 6.8 minus your mean divided by your standard deviation. And well, we can simplify this because we know that this equals 0.25 of the mean. So this equals 6.8 minus your mean over your 0.25 of the mean. So if we find this corresponding z value, then we can find our mean because we have an equation. So let's look at this. So we need to find the z value which corresponds to an area of 0.75. So what is this? What is the z value that corresponds to an area of 0.75? Well, I looked these up before I started, and that is 0.674. But you can just look that up. You look up this on the table, 674. I can just show you how to do it if you want. So you look for where's 0.75 area and what z value corresponds to that. Well, you look here, you get 0.75. Well, where is that? Oh, okay. You got 0.7486. So it's going to be 0.67, and then you add 13.4. So 0.674. So you can just look at that on the table. So what you get there. So therefore, the corresponding z value for your 6.8 is that. So therefore, you can say that you get 0.674 equals to 6.8 minus mu over 0.25 of the mean. So now you've got an equation just for the mean, so you can find the mean. So we do 0.674 25. So we get 0.1685 of the mean equals 6.8 minus mu. So that gives you 1.1. So we take the mean over 0.1685 mu equals 6.8. So we get the mean value equals 5.82. Cool. Let's keep going and do another one. So again, we're given a random variable with an unknown mean and standard deviation, and it is given that the probability that x is less than 7, well, this has the value 0.2119, and the probability that x is less than 10, well, this is the value 0.6700. So let's, again, what we always do is draw out the situation, and we have to find, well, what is the mean and standard deviation? Well, let's draw these out. So we have an unknown mean. So this, when x is less than, probability that x is less than 7 is 0.211. So that means it's on this side. This area here is going to be 0.2119, and this is 7. And that means that this area here is 1 minus 0.2119, which is 0.7881. So we can say the corresponding z-value, we could call it z1, because we know we're going to get 2 here, is equal to, well, 7 minus mu over the standard deviation. And let's also draw out this other situation. So we just know what we need to find. Well, it's less than 10. This is 0.67. Here, this area, that means this area is 0.33. 1 minus that. This is your mu, it's x. So your corresponding z-value, we could call z2 for this situation, is equal to 10 minus mu over the standard deviation. So if we find the corresponding z-values for both of these, then we will have two equations, equation 1 and equation 2, with two unknowns. So then we can find those two unknowns. So let's do that. Let's find first z1. What is that going to be? Let's look at this. Well, your z1 is here. So you can say that if you wanted to find z1, well, the thing you can do is, because z1, if this area here is 0.7881, well, that means that you can say this is the same as saying, because from the table you can find, say, another z, so let's find this z value, because it's symmetric, 0.7881. So if we find this z, we can then find that z. So this z is going to equal to what z corresponds to 0.7881 area. Well, I looked that up as well to save us time, and that z is actually 0.8. So a 0.8 corresponds to a 0.7881 probability or area. So that means that this z1 equals the negative of that. And this is z, so it's negative 0.8 because it's symmetric. Now let's find z2. Well, z2 is from here, where you can see that z2 is just going to correspond to the area of 0.67, but we can draw that out as well if you want. So our z2 will just be, well, what is the z value which corresponds to this area, 0.67? z2, 0.67. Well, the z2, if you look it up on your table that corresponds to that area, it's going to be 0.44. So now you've found your z2 and your z1. So therefore, your equation 1 now becomes, and we did all this so we can find the mean and the standard deviation. So your equation 1 then becomes, well, minus 0.8 equals 7 minus mu over standard deviation. 7 minus mu over the standard deviation. So we could make this simpler. We could say this minus 0.8, standard deviation 7 minus mu. So then our mu equals 7 plus 0.8. So that's one of the equations, and then the second equation we can find by substituting z2 into here. So we get 0.44 equals 10 minus mu over the standard deviation. 10 minus mu over the standard deviation. Let's simplify that as well. And we get mu equals 10 minus 0.44. So now you can see that if we substitute, let's say we substitute the equation 1 into the equation 2, we'll find the standard deviation. So let's substitute this into here. We get that 7 plus 0.8 standard deviations equals 10 minus 0.44 standard deviations. Let's simplify this. This gives us what? 1.24 standard deviations equals 3. So this equals to 3 divided by 1.24, which is 2.42. So there's our standard deviation for this situation. And then if you want to find your mean, well, we can just substitute that back into one of these equations, say this one. So we substitute that back into 1. Well, let's just do it with 2 because I can see it. So we get the mean will then equal, therefore the mean equals to 10 minus 0.44 times this 2.42. So therefore your mean equals is 8.94. So I just rounded these, 8.94. So there you go, that's your mean and that's your standard deviation. Let's do another one of these harder ones. See, these are 5 marks, it's quite a lot. So the lengths of fish of a particular species are modeled by a normal distribution. The scientist measures the lengths of 400 randomly chosen fish of the species and he finds 42. So first of all, we have an unknown mean, standard deviation. So x is our random variable, the length of these fish. And he finds that 42 fish out of the 400 that he selects are less than 12 centimeters. So that means the probability, x, remember x is the, number of fish, or x is the lengths of fish, right? So random variable, and probability that the lengths of the randomly selected fish is less than 12. Well, this equals, there's 42 of them out of the 400, so that equals 42 divided by 400. So out of 400 randomly chosen fish, 42 of them were smaller than 12. So the lengths of the fish were less than 12. That means that the probability is 42 divided by 400. So 42 divided by 400, that equals 0.105. And then it also says that 58 of them were more than 19 centimeters. So the probability that x is greater than 19, well, 58 of them were found to be that out of the 400. So that means the probability of a fish being longer than 19 centimeters is 58 divided by 400, which is 0.145. And it wants us to find estimates for the mean and standard deviation of the lengths of fish, of the species. Well, what do we always do? Draw this stuff out. So let's do that. So we draw it out here. Man, I really think I'd be better at drawing straight lines by now. Okay, so the probability that x is less than 12 is this. So that means that 12 is on this side, and this is your mean. This is 0.105. Well, that means that this area, remaining area, is 1 minus 0.105 is 0.895. And the corresponding z-value for this is going to equal to, and call it z1, is going to be 12 minus mu over the standard deviation. And then we can look at the other one. So I'm using the similar procedure as the previous question. So when it's greater than 19, this is 0.145. So that means this area is 1 minus 0.145. So that's 0.855. And the reason I find this area is because I know I'm going to have to find z-values always correspond to these left areas or probabilities. So we can say our z2 equals 19 minus mu over the standard deviation. So if we find Z1 and Z2, we get two equations relating two unknowns, which means we can find both of those unknowns. So again, let's call these equation 1 and equation 2. So let's find first Z1. Well, Z1 corresponds to this area here, which is 0.105. 105. Remember, this area is 0.895. So if you want to find this, well, let's find first .895. So let's find this. What will this the Z value correspond to this area? Well, let's look that up on the table. The Z that corresponds to this is, and I looked it up, 1.253. That means that this Z1 here, because you can see it's just a reflection, is going to be minus 1.253. Yeah, remember this area will be 0.105. So then let's find Z2. Well, Z2 will just be the Z value, which corresponds to an area of 0.855. So what Z value corresponds to the area of 0.855? Well, you look it up on your table, and I did that before as well, is 1.058. So therefore, the equation 1 becomes 1.253 from here, minus. So Z1 minus 1.253 equals 12 minus mu over the standard deviation, equals 12 minus mu over the standard deviation, which we can simplify. We can say this is 1 minus 2.53. So therefore our mu equals 12 plus 1.253 standard deviations. So our equation 1, and then our equation 2, well, that becomes 1.058 equals to 19 minus mu over the standard deviation. Let's simplify that a bit. We get mu equals 19 minus 1.058 standard deviations. So we have these two equations. So now let's substitute this one into this one, or doesn't matter. So we can find the standard deviation. So let's substitute this in. We get 12 plus 1.253 standard deviations equals 19 minus 1.058 standard deviations. So that gives us 2.311 standard deviations equals, I literally just typed in 19 minus 12. Okay, and then so your standard deviation equals 7 divided by 2.311, which equals 3.03. So that's your standard deviation. And then if you want to find your mean, we just substitute in this equation. So let's substitute into the equation 1, we get the mean will equal 19 minus 1.058 times 3.03 times 1.058, and then that equals 15.8. So you get a mean of 15.8. And so that's a bunch of examples from that resource, which you can get on my Patreon. But that's all from me. Make sure you hit that like button for me, and if you find this stuff useful, please subscribe. But I'll see you in the next video.